Here we are, Chapter 6, Linear Functions. Our first topic today is 6.1, looking at the slope of a line. We know you've done some in the past, but the slope of a line segment on any coordinate grid is a measure of its rate of change. From Chapter 5, remember that the rate of change is the change in the dependent variable, which is the change in y, over the change in x. Now, one of the ways to write that is delta y over delta x. And that's what I know you've learned in science, but that's what I like to use as a little bit of an abbreviation as well. So it's the change in y is called the rise, and the change in the x is called the run. So the slope really is the rise over the run. Here we have some slopes to look at. In roof A, we have a rise, if you can see in yellow, and a run in yellow. The rise is going to be 13 units. The run, if you count them out, the little squares, are also 13 units. So the slope would be 13 over 13, and in this case would reduce to 1. In roof B, similarly, this time the slope will be less. The rise this time is only 7. The run is 12. So the slope will be 7 over 12. It's less than 1. Slope C is steeper. The rise is much greater. This time we have a rise of 14 and we have a run of 8. So the slope is 14 over 8, which reduces to 7 over 4. In example 2, let's determine the slope of a line segment. Well, one of the ways to do this is determine the rise, determine the run. So if we made a little triangle here and we counted the squares, the rise is going to be 1, 2, 3, 4, 5, 6, and the run is going to be 10. So the slope, or change in y over change in x, would be the rise, which is 6, over the run, which is 10, which is 3 over 5. In our second diagram, well, we have something different. It's going down now from C to D. So our rise is going to be a negative number. It's negative 10. It's going down. And our run is still 5, so our slope is going to be negative 10 over 5, which is negative 2. Here's a question for you to work on, so you can stop the tape and then move on to the next example. When a line segment goes up to the right, both y and x are increasing. Both the rise and the run are positive, so the slope is positive. When the line segment goes down to the right, y decreases, x increases. The rise is negative, the run is positive, so the slope is negative. For a horizontal line segment, the change in y is 0 as x increases. So the rise is going to be 0, the run is positive. 0 over any positive number gives us a slope of 0. So the slope of any horizontal line is going to have a slope of 0. In a vertical line, the slope is going to be, or the rise is going to be positive, but the run is going to be 0. And any fraction with a denominator of 0 is not defined. So we say that the slope of a vertical line segment, therefore, is undefined. So here we have positive slope, here we have a negative slope, here's a 0 slope, and lastly an undefined slope. In example 2, let's draw a line segment with these slopes. Well, if we drew a coordinate grid and we pick any point on the grid, here I pick the point negative 2, negative 2. Now we want to have a rise of 7. So we're going to count up 7 units. We're going to have a run of 5. So recall 5 units across, draw another dot, and connect the 2 line segments. In our second one, negative 3/8 is like negative 3 over 8, which gives me a rise of negative 3, which means it's going to go down 3, and a run of positive 8. So if I picked another point on here, say I picked the point x is 1, y is 4, now I can count down 3 units, and I can go over 8 units, draw another point, and draw in my line. The first line sloping up was A, the second line sloping down was B. Examine the slope of a line that passes through C, -5, -3, and 2, 1. Here we have a coordinate grid. Let's plot our points, draw our line segment. Now to find the slope, we can do a couple different things. We can count them physically, or we can subtract the differences between the points. If I subtracted the change in y as y2 minus y1, I would find that I'd start with the point 2, 1, and I could go 1 minus the -3 to get 4, so my rise is going to be 4. I can verify that by physically counting the 4 units. My run will be x2 minus x1. I can subtract the x coordinates. 2 minus -5 would give me 7. So I could find a slope of 4 over 7. Just cleaning this up so what I can say that this leads to a formula that we can use to determine the slope of any line, and the slope of any line can be found A, x1, y1 to B, x2, y2 by saying y2 minus y1 over x2 minus x1. There's a question for you to try before you move on. Interpreting the slope of a line. Yvonne recorded the distance she had traveled at certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba. She went from North Winnipeg to Grand Beach. She plotted the data on the grid. What is the slope between these points? Well, it's important not to just count the squares, but actually look at the units on each of the axes. So when you notice the slope, the rise is up 24, and the run is over 1. So the slope would be 24 over 1, or 24. What does the slope represent? Well, that's the distance, kilometers, and per hour, or 24 kilometers per hour. And that's going to be your rate of change, or your speed for this case. Now, how can the answers in Part B be used to determine how far Yvonne traveled in 1 3/4 hours? Let's use ratios. We can say kilometers per hour has to start out with the given ratio of 24 to 1. Now we want to know how far she can go in 1.75 hours. That must go on the bottom. We'll put x on the top, and we can cross multiply. And when you do that, 24 times 1.75 has to equal x times 1, which is 42 kilometers. And what's the time it took Yvonne to travel 55 kilometers? Well, this time again, we can say kilometers per hour has to be 24 to 1. Now we can put the 55 kilometers on the top and x on the bottom. Cross multiply, and you'll get 24x is equal to 55. Dividing both sides by 24, x is going to equal about 2.3 hours. There's a question for you to try. Just the definition again, the slope of a line is measured as its rate of change, the rise over the run. A positive slope goes up to the right, a negative slope down to the right. A zero slope is a flat line, an undefined slope is a vertical line. The slope through 2 points P and Q can be found by going y2 minus y1 over x2 minus x1. And your assignment for this section is to do page 339, numbers 4 to 9 and 11 to 28.